Good morning, students. You can check the answers for the previous class assignment. Second one is false. Oxygen supports the combustion. Brief answer: physical properties of oxygen. Then answer for the second question: why does the fish die when it is taken out of water? Take it down in your notebook. In our last class, we have started with the composition of air, discovery of oxygen, its occurrence, and physical properties of oxygen. In this class, we start the chemical properties of oxygen. First property, combustibility. Already you know that oxygen is a good supporter of combustion. But does it burn on its own? No. Oxygen is a non-combustible gas. Means what? It does not burn on its own. But it supports the combustion of other substances. If oxygen has the capacity to burn on its own, means even a striking matchstick is enough to burn this whole universe, isn't it? So, the first chemical property, it is a good supporter of combustion. Second property, reaction with metals. The general thing about the action of metal with oxygen is, oxygen reacts with the metals, gives metallic oxide. What is the nature of this metallic oxide? This metal oxide is generally basic in nature. We will see a small experiment to prove this basic nature of metallic oxides.
Take a magnesium ribbon. Hold the ribbon with a pair of tongs. Burn the ribbon using a burner. Collect the ash which is formed by burning the ribbon in a watch glass. Now dissolve the ashes in water. Take both blue and red litmus papers. Dip them in the resultant solution individually. Observe the changes in color of both the litmus papers.
Here the red litmus paper changes to blue. It shows the basic nature of metallic oxide, magnesium oxide. Okay. Metals differ in their reactivity towards oxygen. What does this mean? Some metals are more readily reactive with oxygen, but some metals need some ignition point to react with oxygen. We will see it one by one. First one, at room temperature. First condition, at room temperature. Sodium and potassium are highly reactive. So even at room temperature, they react with oxygen. Sodium react with oxygen to give Na2O. What is it? Sodium oxide. See, here we need to balance this equation. How to balance it? The number of atoms in each element should be equal on both the sides of this arrow. For that, first we take this sodium. Here sodium, one atom only. There you have two atoms. So, we need to put 2 as a common factor to make it balance. Next one, oxygen. Oxygen, here we have 2. But there only one atom, isn't it? So, again we need to put common factor 2 for this and make it as 2 oxygen atoms. But now it becomes 2 into 2, 4 sodium atoms. So, here also You need to put 4. Now it get balanced. One by one we check it. Sodium 4. Here 2 into 2 4. Oxygen 2. 2 times O. Oxygen here also. Do you understand it? Okay. So sodium reacts with oxygen to form sodium oxide. The condition here is room temperature. The same way potassium also reacts with oxygen to form potassium oxide, K2O. Potassium oxide. See, we'll check whether it get balanced. K2 here only 1, so we make this as 2. Oxygen 2, here oxygen 1, so again we will put 2 tappu. So 4 potassium atoms, 2 oxygen gives potassium oxide. The next condition is on heating slightly. Magnesium and calcium, even aluminium, iron also react with oxygen. We will see this one by one. Magnesium reacts with oxygen to form magnesium oxide, MgO. And calcium reacts with oxygen to form CaO, calcium oxide. Now we balance this. Mg plus O2 gives MgO. 2 oxygen, isn't it? No. So, if we put 2 here, it will get balanced. So, here also 2 and 2 calcium. Next condition, at high temperature, some metals like iron, copper, silver reacts with oxygen at high temperature and forms their oxide. Iron reacts with oxygen to form iron oxide. Copper reacts with oxygen to form cupric oxide. Silver reacts with oxygen to form silver oxide. But some metals like gold, platinum, even at high temperature, they do not react with oxygen. So, there is no reaction for these metals. Reaction of oxygen with non-metals. The general reaction, the non-metals reacts with oxygen to form non-metallic oxides. What about the nature of this non-metallic oxides? They are acidic in nature. You know, metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. How can we prove it? Sulfur reacts with oxygen to form sulfur dioxide. When sulfur dioxide dissolved in water, it forms sulfurous acid. This can be confirmed by using the indicator blue litmus. You have already learnt about the indicators in acid-base lesson, no? So this sulfurous acid changes blue litmus paper to red litmus. Next non-metal, carbon. Carbon reacts with oxygen to form carbon dioxide, CO2. Already you know CO2, carbon dioxide. Nitrogen reacts with oxygen to form nitric oxide. What it is? Nitric oxide. Here 2 nitrogen and 2 oxygen here. So you need to balance it by putting 2 as a common factor. Isn't it? Then phosphorus reacts with oxygen to form phosphorus trioxide as well as phosphorus pentaoxide. O5 means phosphorus pentaoxide. Phosphorus trioxide, that is for P2O3. Here it is phosphorus pentaoxide, P2O5. Shall we balance this? Okay. 2 phosphorus here. You need to put 2 here and 3 oxygen. We cannot change this. We put 3 as a common factor here. 3 2s are 6. So again you need to balance here. 3 here. If we put 2 means 2 3s are 6. Then phosphorus will become 2 2s are 4. Then here 5 penta, isn't it? So if we put 5 here means it will become 5 2s are 10. If we put 2 here means 2 5s are 10. Again 2 2s are 4. Next chemical property of oxygen is reaction with hydrocarbons. What are hydrocarbons? The compounds which contain hydrogen and carbon. Generally, solid hydrocarbons, wood, and liquid hydrocarbons, petrol, diesel, even gaseous state, LPG. All these compounds are called hydrocarbons. When they react with oxygen, hydrocarbons reacts with oxygen to form carbon dioxide, water vapor, along with lot of heat and light energy. Because of this production of heat and this light energy, these hydrocarbons are generally used for fuels. The hydrocarbons are used as fuels. What is the general equation? Hydrocarbons reacts with oxygen to give carbon dioxide, water vapor, heat and light. Another one chemical property is rusting. Already you have learnt it so many times. Still I want to remind it. The process of conversion of iron into hydrated iron oxide. How it forms? Fe plus O2 gives Fe2O3. Here 3 times 6. Here 2 times 4. Again this iron oxide in presence of water vapor, because rusting happen in the presence of moisture as well as oxygen, isn't it? So this you can take it as X number. X may vary depending upon the moisture condition of the atmosphere. Fe2O3 X H2O. This is hydrated ferric oxide, which is general formula for rust. Okay, so this X is the variable number. Sources of oxygen. We know oxygen from air is responsible for respiration. So plants, animals, even human beings use this oxygen for their respiration.
Oxygen is also used for artificial respiration. They are used by scuba divers,
the people who dives deep into the seas and oceans, mountaineers, astronauts and patients who needs the support of oxygen in hospitals. Nowadays we heard about it, isn't it? That is for the corona patients, the ventilators or artificial support of oxygen. They also used as a cutting and welding purpose. For this cutting and welding purpose, oxyacetylene flame. It's a combination of oxygen, hydrogen and acetylene. Then it is used to remove carbon impurities from steel. Then used to oxidize rocket fuel. The common formula for this liquid oxygen LOX. The next one, it is used as an explosives when particularly mixed with powdered charcoal. The last one, it is used for the synthesis of methanol and ammonia. Ammonia is a good fertilizer. It is a main ingredient for all kind of fertilizers. So today we have discussed about the chemical properties of oxygen, uses of oxygen also. Now it's time for your assignment. Thank you.